Okay, let's open up our workbook to page 73. Notice this lesson deals with the term slope. All right, it deals with recycling. It says Hero Comics prints, so that's some company, they print on recycled paper. The table shows the total number of pounds of recycled paper that has been used each day during the month. And so noticing here, here's the number of pounds for each day. Actually, it's not for each day, but it's totaled by that day. Like, for example, by the 6th day, they have used 72 pounds of recycled paper. All right, so we need to graph it. Now, this is our X, and this is our Y. So let's see, 336. 336, so I go over 3, that's halfway, and then I go up to 36. Now that's going to be kind of hard to tell. It's somewhere between 25 and 50, almost halfway, let's say. So 336, so I'm going to go about halfway. And you know what I'm going to do is make the dot large. So that way it's kind of a way of fudging a little bit. All right, let's do 560. 5 and then go up 60. Whereas 60, that's between 50 and 75. It's right in the middle, actually. So right in the center there. Next one, 6 and 72. 6 and 72. So let me kind of zoom in so you can see a little bit better. So 6, I go over 6, and I go up to 72. Well, here's 75. So 72 is right below it. And you can see I'm kind of off right now, but that's 6 and 72. What's the other one? 7 and 84. 7 and 84. That's a little less than halfway. Boy, it's really hard to tell, huh? Next one is 12, 144. Remember, this is where I'm getting my numbers from. 12, 144. So I go over 12 and up to 144. That's pretty close to 150. Okay, so there we are. So it's roughly a line there. I'm going to draw a straight line through it. So roughly, that's what it looks like. And boy, yeah, it's very hard to tell when the grid is not lined up like you like, the numbers. It's very hard to graph it. Okay, so the question here, explain why the graph is linear. Linear means it makes up a line. Okay, so what can we say here? The points lie, they're resting on a straight line. See that? If I drew a line there, these points would be resting right on it. They'd be laying on it. The points lie on a straight line. You could say the points make up a straight line. You could say that. All right, next, use 2 points to find the constant rate of change. Okay, so we need 2 points. And I can tell by looking at the numbers, they want us to use the first 2 points. So we will do that. So the first point was 336. And the other point is 560. Okay, where am I getting those numbers from? I'm getting those numbers from up here. 336, 560. See that? right there. That's where I'm getting those points from. All right, now let's find the change in the pounds. That's the change in the y. 36 to 60. If I subtract those, 60 minus 36, I would end up with 24, right? That's the change in the y. How about the change in the x? From 3 to 2? That's just 2. So the constant rate of change is 24 divided by 2. Or you could say 2 goes into 24 12 times. 12 pounds per day. That is the constant rate. But we know it also has the name of slope. Just real quick, sometimes the numbers aren't nice and consecutive. Like 3, then it skips to 5, 6, 7, then it skips to 12. So if I looked at this, 36 to 60, that is 24. 3 to 5, that's 2. That change is 12. 24 divided by 2 is 12. Now if I go from 60 to 72, that's 12. And this is 1. That change is 12. If I go from 6 to 7, that's 1. From there to there, that's 12. 72 to 84. 12 divided, that's 12. You see that? It'll still be 12 over 1 when it's reduced. That's the change. You just have to be careful if it's not consecutive, if it's not in a row. Okay, go ahead and turn the page, please. Okay, this term slope, it's the rate of change between any 2 points on a line. Okay, it's like a constant rate of change. And notice in this case, it goes up 2 over 1, up 2 over 1. The y is changing by 2, and the x is changing by 1. And that's just what we found out. And then here it is here. The ratio is called the slope of the function. Okay, we don't need to get into that now. But the constant rate of change, or unit rate, is the same as the slope of the related linear relationship. It's the same as the slope. It's another word for it. And the slope tells us how steep the line is. The vertical change is sometimes called the rise, while the horizontal change is called the run. You can say that slope is rise over run. It's the change of x over change of y. See, the rise goes up and then over to the next point. Up and then over to the next point. So looking at this graph real quick, notice that the y from here to there, that's 1, 2, 3 spaces. And the run going sideways from here to there is 1, 2 spaces. See, the change of y going up down is 3, the change of x is 2. 3 over 2, that's the slope. Or we could also say that is the constant of proportionality. Sorry, you didn't see that. Okay, turn to page 75, the next page over, slide it over. And look at this example. It says the table shows the relationship between the number of seconds it takes to hear thunder after a lightning strike and the miles. So we have seconds and miles you are from the lightning. Graph the data to find the slope. So notice that when you hear thunder, that means the light, like after 5 seconds, it means it's 1 mile away. If it takes 10 seconds between the thunder and the lightning, between the lightning and the thunder, excuse me, see that? If it takes 10 seconds, then it would be 2 miles away. I always thought it was 3 seconds for every mile, but I guess it's 5 seconds for every mile in this table. And notice they do the change of y over the change of x. Now notice that they subtract. You don't need to subtract. You can just add as you're going along here. You can see that it goes up 5 over 1. Up 5 over 1. 5 over 1. Right? And notice what they have as the answer. 5 over 1. Okay, now let's go to our problem. Letter A. Graph the data about the plant height for a science fair project. Then find the slope of the line. Explain what the slope represents in the work zone. Okay, this is our work zone over here. So here's our data. So week 1, it is 1.5, so 1.5 meters high, centimeters high at week 1. So 1, and then go up 1.5. Again, I'm going to make my dot large. Next one is 2, 3. Go over 2, up 3. Over 2, up 3. Over 3, up 4.5. Over 3, up 4, and then a half. Over 4, up 6. Over 4, and up to 6. All right, and we can draw a line through that. Okay, explain what the slope represents. Oh, it says find the slope of the line. Notice that it goes up 1.5 over 1. It goes up 1.5 over 1. 1.5 over 1. 1.5 over 1. Okay, and you could even count right here. See that? That's 1.5. That's 1.5. 1.5, 1.5, and here it's just going to go, it's just changing by 1. But you could look at the graph and also tell that, right? So what's the slope of the line then? It's 1.5 over 1. So I'm going to say that slope equals 1.5, I'll just say 1.5. Well, 1.5 over 1. Okay, what does that mean? It means 1.5, what's our units? Centimeters per, what? 1 week. It grows, right? That's what it's saying. It grows. I could say it grows. Sorry here. I wasn't planning this out very well. It grows 1.5 centimeters per 1 week. The plant does. Talking about plant growth. Okay, turn the page, please. We're on page 76. Let's look at the top. Quick look at this example. And this Ronaldo, he opens a savings account, and each week he puts in $300. So apparently he has no money the first time, and then each week he adds $300, which seems kind of weird to me because usually you got to put money into it. But here it is, $300 per week. Okay, that's the slope, 300 over 1. Okay, so now let's look at our little example to do right here. It says Jessica has a balance of $35. So she already starts off with $35 on her cell phone account. She adds $10 each week. $10 a week for the next 4 weeks. In the work zone, graph the account balance versus time. Find the numerical value of the slope and interpret it in words. Okay, so starts off with 35 and then adds 10 each week. Okay, so looking over here, work with me, book. Your workbook, work with me. So she's going to start off with $35 in her account. She starts off. So that means at 35, oh wow, this is really let's see, this right in the middle would be 30, right? So 35 is a little bit higher. So it's just below the 40 is $35. Just below the 40. That's where we're going to start. And then she adds $10 per week. $10. So if it was 35, you know what? Maybe I should just make a little table of this. That surely would. Why didn't they put a table for me? I don't know. You know what? It makes more sense to me. So 35, at 0, it's 35. At 1 week, it's $10 more. That's 45. The next week, it goes up another $10. 55. 65. Like that. But it starts at 35. So I start at 35. And now I go up to 45. 145. So much easier with a table. So I go 1 and up to 45. That's a little bit over 40. Again, make the dots large. That's my cheating way of doing it. Next one, 255. So I go over 2. I go up to 55. That's a little under the 60. And then 365. 365. I go to 3 up to 65. That's a little over the 60. And you can see it's making a nice straight line. So draw a quick little line through there. Hopefully you can see that it is not proportional. It's not proportional. It still has a slope though. It's just not the unit rate. So let's see, how much is it changing? How much is it changing? It goes up 10 over, remember if you look over here at this, it's changing by 10, right? And over here it's just changing by 1. 10 over 1. That's the slope, 10 over 1. What does that mean? Excuse me. 10 over 1. So what does that mean? That's 10 what? Dollars in 1 week? $10 in 1 week. So her account changes $10 per week. How about, I'm just going to make this really short. I'm going to say gains $10 per week. Wow, that is really not very good with my words, am I? But there's not much room to write in here either. She gains $10 per week. That's what it means. Let's go to the guided practice. It says the table at the right over here, shows the number of small packs of fruit snacks. Okay, fruit snacks per box. Graph the data. Then find the slope of the line. Explain what slope represents. All right, so let's graph this then. Now usually, okay, look, they put the X and the Y already right on there. Excuse me. So that's good. So 312 is our first one we have. 312. And if you get confused on this, you can always just make a little T table right here and put the numbers in if it helps you. Just make sure you put the right numbers in there. And 728. Okay, sorry about that. That's a 12. So let's see, 312, 520. So going over here, 312, go over 3, up 12. The next one is 520. I go over 5, up to 20. The next one is 728. And I'll just draw a little line through that. Notice it does go through the origin. And it is straight. Okay, so what is the slope? What is the slope? If you want to, you could count, looking at the graph, you could count it. Notice from 12 to 20, it goes up 8 and then over 2. I'm going to write that in there, but you don't have to. But I am going to, because I dig it. 8. See, if it goes up this way, that's 8. And if it goes and sideways, it's going over 2. 12 to 20 is 8. If you look at this, 20 to 28 is 8. And then going sideways, it's only going over 2. You see that? The rise is 8 and sideways is 2. So it's going to be 8 over 2, or you could say 4 over 1. Okay, that's the slope, 4 over 1. Okay, what does that mean? And by the way, you could have just looked at this. This changes by 2, changes by 2, changes by 8, changes by 8. See that? 8 over 2. That's the slope, or you could reduce it to 4 over 1. That's our slope. Okay, what does it mean? Now, let's just clarify. In this classroom, for this part, let's just put down the units, all right? So 4 for what? For packs. Remember, it's packs of fruit per one what? One box. Okay, so these are packs of fruit. These are boxes. 4 packs per 1 box. That is the slope. That's what it stands for. That's what it represents. Okay, what's another name for this right here? This slope. What's another name for this slope is the question. Okay, let's turn to the next page. You're going to be doing these problems, but I just want to do a couple of them with you. And it has to do with number 3, because there's a couple of questions that are a little weird. Not too sure how to answer them. So let's look at this together. Number 3. You can do 1 and 2, just a minute. The graph shows the average speed of 2 cars on the highway. There's 2 cars. One is car A, and there's car B. All right. You can answer these 2 questions, but I'd like to help you on C and D. Let me help you answer those 2 questions. It says, what does the ratio of the y-coordinate to the x-coordinate for each pair of points on the graph represent? So the y over the x, or at that point of time, what does it represent? Okay, so for example, at this point right here, what would it represent? These 2 numbers, like 290, for example, what would it represent? It would represent the speed at that time. I would not expect you to be able to know this. So the speed at that particular time, that's the speed. What does the slope of the line represent? The average speed. Okay, I would not expect you to know these 2 answers. I wasn't too sure what they were asking for when I saw it, so Anyways, the rest of it you can answer. All right, so you go ahead and you finish up this page, please. Page 77.